Have you ever looked at an Intel processor and wondered what all those numbers and letters actually mean? What's the difference between an Intel Core i5 and an i7? What does 14700K mean? Why are some processors faster than others? In this video, I'm just going to explain the basics of Intel processors so that you can have a basic understanding when you're choosing your next PC or when you're choosing the processor for your next CPU build. The processor, also called the CPU or central processing unit, is often referred to as the brain of a computer. Every action you perform on a PC eventually reaches the CPU. Opening applications, playing games, editing videos, browsing the web, running Windows, this all goes through the CPU. The CPU receives instructions, processes them, and sends the results to other components. Think of it like a restaurant kitchen. The customer places an order, the chef receives the instructions, the chef prepares the meal gets delivered. In a computer, the CPU is the chef. The faster and more capable the chef, the faster the computer performs the task. Intel offers several processor families. We got the Intel processor. These are entry-level chips designed for basic tasks like browsing, email, office work, and streaming videos. Then we've got the Intel Core series. This is Intel's most popular lineup. Examples include the Core i3, the Core i5, the Core i7, and the Core i9. These processors target gamers, professionals, and everyday users. The Core i3, this is the budget option. It's for everyday computing and basic gaming. The Core i5 is the mid-range option. It has excellent value and it's great for gaming. The Core i7 is the high-performance option. It's for heavy multitasking and advanced level content creation. And lastly, we got the Core i9. This is the enthusiast level. It's for professional workloads and extreme performance. Next, we got the Intel Xeon. Xeon processors are designed for servers, data centers, workstations, and enterprise applications. Xeon processors focus on reliability, scalability, and heavy workloads. So to make this easy, let me decode a processor name. Let's take, for example, an i7 14700K. Every part has a meaning. The Core i7 part, this identifies the performance tier. The 14 in 14700K, the first two digits represent the generation. 14 means 14th generation Intel processor. Generally, newer generations bring better efficiency, higher performance, and improved features. 700. These digits indicate the processor's position within its family. Higher numbers usually mean more cores, more cache, and higher performance. For example, an i7 14700 is stronger than an i7 14500. K. The letter at the end provides additional information. Common Intel suffixes include: if it's a K, it means it's unlocked for overclocking. KF means it's overclockable but it has no integrated graphics. An F means it has no integrated graphics. A T means it has lower power consumption. H is high performance laptop. HX, it stands for it's a extreme laptop performance. U is for ultra low power laptops. P is for performance thin and light laptops. Imagine a CPU core as a worker. A single core processor has one worker and a quad core processor has 4 workers. Basically, more workers can complete more tasks simultaneously, which means a quad core processor can do the same task faster than a single core processor because it has more workers doing the work at the same time. Modern CPUs commonly feature between 4 cores to 24 cores. Intel also uses hyperthreading. This allows one physical core to handle 2 threads simultaneously. For example, 8 cores plus hyperthreading equals 16 threads. In more realistic terms, you can look at it like this. If one core is equal to 1 worker, 2 threads, it means that one worker has 2 assistants, which means they perform the task faster. More threads improve multitasking, video editing, streaming, and rendering. Modern Intel processors use a hybrid architecture. Instead of having identical cores, Intel uses 2 types: performance cores and efficiency cores. Performance cores are designed for gaming, heavy workloads, and single-threaded performance. These are the powerful cores that are used for heavy tasks. Then we got the efficiency cores. These have lower clock speeds and use less power. They are designed for background tasks, light workloads, and power efficiency. This hybrid design improves performance, battery life, and power efficiency. Clock speed is measured in gigahertz. A CPU running at 3 GHz can perform approximately 3 billion cycles per second. Higher clock speeds generally mean faster performance. However, a 5 GHz processor is not automatically faster than a 4 GHz processor. Architecture, cache, and core design also matter. That's why modern CPUs are evaluated using multiple performance factors. Cache is ultra-fast memory built directly into the CPU. So the processor, instead of repeatedly accessing slower RAM, the processor stores frequently used information inside the cache. There are typically 3 levels of cache memory. We got the L1 cache, which is the fastest and smallest of the 3. We got the L2 cache, which is larger but slightly slower. Then finally we got the L3 cache, largest of them all but slower than L1 and the L2 cache. More cache often improves gaming productivity and overall responsiveness. Many Intel processors include integrated graphics. These processors have the CPU and the GPU on the same chip. This means the CPU can display images without a dedicated graphics card, which is very useful for office computers, school computers, and for media consumption. Intel integrated graphics often come as either Intel HD graphics or Intel Ultra HD graphics or Intel Iris Xe graphics, with the Intel Iris Xe graphics being the highest performer of all the three. However, dedicated graphics cards remain far superior for heavy tasks like gaming, video editing, and 3D rendering. As for integrated graphics, the higher the generation of your processor, the better the Intel Iris graphics performs, or any of the Intel integrated graphics. What also matters for integrated graphics is RAM. The more RAM you have, the more the Intel integrated graphics performs. So that's the basics of Intel processors and processors in general. If this video helped you understand Intel processors, leave a like, subscribe for more PC and tech guys, and let me know in the comments what processor you are currently using. Thanks for watching, and I'll see you in the next video.